There is no monster in any horror movie that can compete with a black hole. It is the perfect villain. It's invisible, it's silent, and it's patient. It is a hole in reality itself, a spot where the laws of physics go to die. Pop culture has painted a clear picture. It's the universe's ultimate vacuum cleaner, a cosmic kraken waiting in the dark to suck up unsuspecting starships. It is the embodiment of absolute, final destruction. Now, look at this picture. The majestic, swirling spiral of our Milky Way galaxy. It's a cosmic city of hundreds of billions of stars, a place of breathtaking beauty, structure, and stability. A place we call home. But what if I told you that the only reason this beautiful, orderly picture exists is because of the monster from the first one? What if the most destructive force in the entire universe is also the single most important creative force? Are black holes the universe's delete key, erasing matter from existence? Or are they the master architects, the cosmic sculptors that build everything we see? Let's start with the horror story, because it is a good one. A black hole is cosmic terror perfected. It is not an object so much as it is an effect. It is a spot where gravity has gone completely insane. It's become so powerful that it has basically declared martial law on space-time itself. The most famous part is the event horizon. This isn't a physical surface you could bump into, it's scarier than that. It is the point of no return. Imagine space-time as a river flowing towards a massive waterfall. The event horizon is the point in the river where the current becomes faster than your boat's engine. No matter how hard you paddle, no matter what you do, you are going over the edge. Except here, the boat is you, and the engine is the speed of light. Even light, the fastest thing in the universe, isn't fast enough to escape. That's why it's black. It's a one-way door in the universe. And what happens when you cross it? Well, it's not pretty. You get to experience a charming process called spaghettification. Seriously, that's the real scientific term. The gravity of a black hole is so extreme that the pull on your feet would be millions of times stronger than the pull on your head. This difference in force would stretch you. First, you'd feel a light tug, then you'd be pulled and elongated, thinner and thinner, longer and longer, until your body is stretched into a literal string of atoms thousands of miles long. You become a piece of human spaghetti, flowing into the void. It is, without a doubt, the most ridiculous and horrifying way to die imaginable. And if that's not weird enough, there's the time distortion. As you get closer to the event horizon, time for you starts to slow down relative to the outside universe. If your friends were watching you from a safe distance, they wouldn't see you get spaghettified. They would see you slow down, get dimmer and redder, and seem to freeze at the edge of the horizon for eternity. But from your perspective, as you fall in, you would see the entire future of the universe flash before your eyes in a matter of seconds. You'd see stars born and die, galaxies collide, and maybe even the end of time itself, all in the instant before you're shredded into atomic pasta. So, to recap, they are invisible abysses that warp time, stretch you into pasta, and erase you from existence. Sounds pretty evil, right? Case closed. But what if all that destruction is just cosmic recycling? The cosmic monster story gets even better when you learn where they come from. Black holes are born from death. When a truly massive star, many times bigger than our sun, runs out of fuel, it can no longer hold itself up against its own immense gravity. The core collapses catastrophically, triggering a supernova, one of the most violent explosions in the universe, briefly outshining an entire galaxy. But after the fireworks, what's left behind is the star's corpse, a core so unbelievably dense that its gravity goes off the charts, and it literally crushes itself out of existence, leaving a black hole in its place. It is a zombie star, and its only remaining purpose is to eat. Now, I do have some good news and bad news about the whole spaghettification thing. The good news is, for a truly huge, supermassive black hole like the one at our galaxy's center, the event horizon is so enormous that the curve of space-time is actually quite gentle. The difference in gravity between your head and your feet would be almost zero, so you could sail right across the event horizon completely intact. No spaghettification. The bad news is, well, everything else. The horror here is quieter. You wouldn't even know you'd crossed a boundary. But you have. You've walked through a door that only opens one way, and the room on the other side is collapsing. You are now inside a pocket of reality that is falling toward a single point, and you have no choice but to fall with it. It's a calmer, more existential, and frankly, much creepier kind of doom. And the big ones? Their eating habits are the most spectacular displays of violence in the entire cosmos. When they feast on huge clouds of gas and dust, it forms a swirling, congested traffic jam called an accretion disk. The friction heats the material to millions of degrees, creating quasars that outshine entire galaxies. It is the light show from a cosmic feeding frenzy, the last scream of matter before it's annihilated. So they're born from death. They can kill you gently or violently, and their table manners are the most destructive spectacle in the universe. But here's the plot twist. Without these monsters, you and I probably wouldn't be here. Let's start at home, in the Milky Way. At the very center of our galaxy sits Sagittarius A star. It is our supermassive black hole, a quiet giant with a mass of 4 million suns. For a long time, we saw it as a monster lurking in the heart of our city. But we were looking at it all wrong. It's not a monster in our galaxy. It is the reason for our galaxy. It's the gravitational anchor, the central pillar, the axle around which the entire Milky Way rotates. All 200 billion stars, including our sun, are circling Sagittarius A star in a vast, stable, cosmic dance. Without that massive, central anchor point, the stars would just be a loose association that would have drifted apart billions of years ago. Our black hole isn't a shepherd hunting the flock. It's the shepherd that keeps the flock together. In fact, the current thinking is that supermassive black holes don't just happen to be in the center of galaxies. They might be the seeds from which galaxies grow in the first place. Early in the universe, these giant black holes may have formed first, and their incredible gravity acted as a cosmic gathering point, a seed that collected the vast clouds of primordial gas and dust needed to kickstart the formation of the very first stars and galaxies. They didn't move into a pre-built city. They were the first cornerstone around which the entire city was built. But the story gets even weirder. They don't just build galaxies, they manage them. Remember those quasars? As the black hole gobbles up gas and dust, it's a messy eater. Massive amounts of energy are blasted back out into the galaxy in two colossal jets that travel at nearly the speed of light. This outflow acts like a galactic-scale shockwave, compressing clouds of gas and igniting furious new waves of star birth. This process is a feedback loop. While the outflow is triggering star birth way out in the galactic suburbs, it's also blowing gas away from the black hole itself, cutting off its own food supply. So the black hole eats, which triggers star formation, which also starves the black hole, which causes it to quiet down and allows the galaxy to stabilize. It's the universe's thermostat. It regulates the galaxy's growth for billions of years. And the elements of life itself, the carbon, the oxygen, the iron, were forged in events that are orchestrated by the gravitational dance around this central anchor. But just when you think you have a handle on this, the universe throws another curveball. Because it turns out, black holes aren't all actually permanent. According to the late, great Stephen Hawking, they have a leak. This is where it gets really weird. The vacuum of space isn't really empty. It's a fizzing, bubbling soup of virtual particles that pop into existence in pairs, then immediately annihilate each other. It's happening all around you right now. Usually, it balances out. But if a pair of these particles pops into existence right at the edge of an event horizon, one can fall in while the other escapes. From our perspective, it looks like the black hole just spat out a particle. It just radiated a tiny bit of energy. This is called Hawking radiation. And here's the catch. That escaping particle's energy has to come from somewhere. It comes from the black hole's own mass. So with every particle that escapes, the black hole gets a tiny bit smaller. It's on a cosmic diet it never signed up for. The universe has a strict no ravens policy, but it seems to have a bizarre loophole for returns. Now, this process is unbelievably slow. For a normal black hole, it would take trillions upon trillions of years, way longer than the current age of the universe, for it to completely evaporate into nothing. But this raises a terrifying question. If a black hole evaporates, what happens to the information about everything it ever ate? One of the fundamental laws of physics is that information can never be destroyed. The universe remembers everything, so if you fall into a black hole and that black hole eventually disappears, where did you go? This is the information paradox, and it's one of the biggest unsolved mysteries in all of physics, which leads to the wildest plot twist of all: white holes. Some physicists, trying to solve the information paradox, have theorized that the ultimate answer is that a black hole isn't a stomach. It's a doorway. They speculate that what falls into a black hole might get tunneled through a wormhole in space-time and come spewing out of a white hole somewhere else. Another place in our universe, or maybe another universe entirely. A white hole is the perfect opposite. You can never enter it, and stuff can only ever come out. It's a cosmic exhaust pipe. It's highly speculative, but it would mean a black hole's ultimate purpose isn't destruction or even creation, it's transportation. So, the paradox of the black hole teaches us that the universe doesn't see destruction and creation as opposites. They are part of the same engine. And maybe even that isn't the full story. Maybe the universe is even stranger, and these cosmic monsters are actually cosmic ferrymen, transporting the building blocks of reality from one cosmic shore to another. A black hole isn't a cosmic vacuum cleaner. It's more like a heart. At its absolute center is an impossibly violent crush. But the powerful rhythmic pulse of its gravity is what anchors the whole system and circulates the energy that allows the entire galactic body to live and breathe. It is the dark, unseen heart that gives our galaxy life. And maybe, just maybe, it has a secret back door leading somewhere else entirely. What's another thing in science or life that seems totally destructive on the surface, but is actually creative underneath? Let me know your best examples in the comments. And if we just made you feel a little cozier about living in a galaxy with a 4 million sun monster at its center, be sure to subscribe to the Weirdly Brilliant channel for more cosmic revelations.